welcome back to this episode of a Kongcast. My name is Viktor Gamov and I'm a developer advocate with Kong. In a Kongcast, we're talking about all things cloud, connectivity, and Kong. And today I'm still at the DevNexus conference in Atlanta, Georgia. And today I'm extremely excited to be joined by my friend and also the conference speaker, Grace Jansen.
Hi.
Grace, great to have you on the Kongcast.
Thank you so much for inviting me. It's great to join.
We are in Atlanta.
Yes.
And we're doing offline conferences, finally.
Yeah, at last. It's been a while.
Yeah, and that's great. And it's great to have you. And you were speaking here today.
Yes, yeah. So for those of you who don't know me, I'm a developer advocate at IBM, hence the t-shirt. And I focus a lot on like Java, cloud native technologies, reactive, all that fun stuff. And yeah, I had 2 sessions today at the conference, so it's been a busy, hectic day. I was looking at, one talk was on how do we do stateful applications in a cloud native manner? And the second talk was around biology and how we can learn security lessons from Mother Nature.
Yeah.
I have a biology degree before I went to the dark side and joined tech.
Yeah.
So yeah, I like to combine them.
So let's start with like a boring stuff.
Yeah.
Let's talk about the stateful workloads in a cloud environment.
Yep.
Like, what's all the fuss about? Like, what's the problem? What's the problem, right?
Right, so it's this whole thing of, if you look at definitions of cloud native, so many definitions focus on this fact of it has to be stateless, you have to have stateless microservices and all this sort of stuff, and realistically...
Yeah, if it goes down, it doesn't matter, right?
Yeah, this is the whole thing, right? It's about portability, flexibility, cloud native behaviors, which is all great. But realistically, we have to have stateful applications sometimes. It's not necessarily a choice.
Databases, like we need to remember.
Precisely, persistence, whatever that is, however you do it, whether it's a database, Cassandra, etc., Kafka, we're going to have some kind of persistence in there. And so it's about, okay, how do we take these more brownfield applications that we're trying to migrate to the cloud and effectively enable that persistence in a cloud native manner? So it's about enabling things like looking at methodologies like the 12-factor app methodology, looking at reactive applications, using patterns like Saga patterns, or there's long-running actions. All of these sort of developments within the cloud native infrastructure that allow us to do it in a more cloud native way. So that's what we're kind of exploring in the talk.
So at IBM, like, what is the current the thing around the cloud, the strategy? Like, what's the IBM is doing these days around this? Is it like around Kubernetes, or maybe we're still in Cloud Foundry, or maybe it's something, because IBM is doing a lot of things.
Yeah.
If you go to any open source project around like a cloud and serverless, like IBM is doing things like there was a what's the serverless functions project? There was the Apache. Remind me, what was the name?
I can't think of which one it is.
It was the function as a service project.
I don't think I was involved in that.
Okay.
Not sure. But yeah, we are doing a lot, especially open source. Like, we love supporting the open source community. Yeah. And so, yeah, we've been doing a bunch of stuff like, for example, one of them I mentioned was LRA, so long running actions. Yeah. And so we've been helping with the MicroProfile community. So they now have an API called long running actions, which is a great way of looking at sort of persisting state, especially if you have actions and transactions that span across, like, I guess, multiple mini transactions within those transactions. Yeah. So that can really help with that. So we're involved in that.
This? Like, isn't it like something that we try to fix and teach them to do, not to do with things like event store and things like that? But why people still like love their transactions?
So I guess it's a case of, it really depends on the application, right? It depends on, can you switch to something like event sourcing, or do you have to do transactions in some manner? And also it's a case of, it takes a lot of energy and effort and resources to completely change every aspect of your application. Yeah. So if we can help get customers and clients who have perhaps older databases or older applications and move them to the cloud through techniques like LRA, then at least maybe over time, maybe they can switch to something else that's a bit more cloud native in terms of principles, but at least it helps them to get to the cloud and to do it in a more cloud native manner. It's a really cool technology. It's still sort of just getting worked on. Yeah. So there's a lot of work happening within that space.
So how does it work, like underneath, inside of where the state would be persisted, and how this would be transferred in case of like a failure of one of the nodes? Because Serverless, it's nothing like someone else's computer. And when you run it on your own computer, it's a file on your own computer.
Yeah. And that's one of the classic challenges with cloud native, right?
Yeah.
Is the whole like, when you're running it locally, you don't have all the issues of distributed computing, right? You don't have the issue of like, you can just look at the logs, you can just debug something straight away. And so that's where like it becomes important to have the basic understanding of like, right, how is this gonna work in a distributed environment? Like, where is my logging coming from? Have I got observability in there? Am I getting metrics from it? It becomes like a whole host of new challenges, and persisting state is just one of them. There's a ton of other challenges out there where, you know, that's what I mean by sometimes moving from, say, a more monolithic application that's perhaps more established to completely cloud native is huge.
Yeah.
So breaking it down into smaller steps can really help and enable them to do it one step at a time, if you know what I mean.
Yeah, and when we start breaking the things down, we need to, like we were talking like classic the task of like bringing down the monolith, right? So we need to think about the stuff, how these the monolithical components, like microservice of this monolithical system, how they will communicate to each other, right?
Yep.
So it can be like API calls, and can be event store and like a messaging and the things around the Kafka and event streaming and things like that.
Yeah.
Right. So what's your favorite pattern that you know talking to customers, to users, like if we like breaking down and bringing things one by one?
Yep.
What would you suggest people to look at as a communication layer for the services?
Yeah. As you say, there's so many choices out there. It is really like an array, like almost too much choice in terms of trying to pick one.
Exactly. Yeah, that's the problem. Like the problem is not like we have nothing. We have it too much, and that's why users and like the people in the conferences they looking for these answers and like what kind of things will make sense for them.
Yeah.
Like for a long time, I was like a huge proponent of kind of like event-driven approach, right? When we not communicating directly, so it's not like we're not gonna call you, but rather we'll leave you a message and you will pick it up whenever you want. There's approach with the we're gonna take the component, we will mimic it to kind of doing remote call, but we will mimic it as a local call, and we'll do kind of like a remote procedure call type of stuff with gRPC and some other technologies. So what's also available there, and like what you would recommend personally to for this type of task?
So like last year, you might know that I was speaking a lot with Kaitlyn, who was working on a lot of Kafka stuff, and that really opened up my eyes to the whole like event streaming like area, because I hadn't really explored it that much. I love the fact that Kafka enables you to be able to connect in with so many different applications because it's so driven by the open source community, which I love. So I put Kafka as a personal favorite of mine, and it links so well into reactive and into those like cloud native behaviors and characteristics. So for me, I think it's a fantastic opportunity to be able to try it because it's so available. It's not like you're saying, oh, well, now you need a new license because you now have to buy this product and this product. And like, if you're interested in trying out some event sourcing and event messaging and really enabling that asynchronicity at the communication layer, I think Kafka can be a great starting point to give it a go, try it out, see how the connections are with your particular application and the stack that you're using. Because most of the time, there's connections of some kind into Kafka to be able to allow you to try it.
So you mentioned this, we mentioned this a lot of times in this podcast, talking about like a cloud native applications and stuff like that. What makes it cloud native? Like, and
this is like the $1 million question, right?
Exactly. Yes.
So like I was doing a bit of research into it because I have a whole talk around what does it really mean? We use this term so much and everyone seems to have different definitions of it. Yeah. Like if you look at various vendors who've been doing cloud native for ages, some of them state, oh, it has to be microservices. Some of them say it has to be serverless, has to be stateless, sorry. And there's various different definitions. I think for me, really, when you take all of those definitions and you take out like specific architectures or specific languages or specific platforms, when you actually boil it down, for me, it's a set of characteristics and behaviors. And really what it boils down to is having applications that are responsive, so performant, that are able to perform well under whatever load you throw at them and whatever conditions they're in. Applications that are able to be scalable and elastic. So being able to rapidly go not just up, but also back down again to be able to be cost effective.
Exactly.
And applications that really deliver this sort of resilient behaviors that we need. So having things like fault tolerance built in, having these behaviors where, because inevitably something's going to go wrong at some point. Yeah. You might be depending on some other service, or maybe your infrastructure goes down.
Yeah, you don't want to go this like cascading failures to happen. Like you depend on the service that depends on another service, and now you have
you have the problem, right? Yeah. So being able to predict those failures and have behavior inbuilt into your application that enables you to still perform a function, allow a service to occur. I think these three sort of sum it up in terms of, well, actually, you know, in cloud native, we're looking at observability and enabling rapid deployment, and all of these things actually at the end of the day are enabling these behaviors. So for me, it's those core principles that really we're trying to strive to achieve when we're building cloud native applications.
Okay, so many of you listeners, if you're watching this, you're doing the right thing. If you're listening to this, go to our YouTube channel and watch the Kongcast on YouTube, because this is the right way to consume this type of content. We ask our guests to bring some interesting demo, and I also asked Grace that she will record, and we will using the magic of the movie editing and all this kind of stuff. We'll bring this in because being in a conference, it's a little bit joy because we're kind of getting back to normal life. But it also is a stress for the speakers because you need to make sure that the things that they will do in have a good content. They still kind of the application is up and running. Like Grace made
Pray to the demo gods.
Exactly. couple hours ago when in the hallway, and I was super focused on the stuff that didn't work before my talk, but I was able to fix it. So Grace, what you will be showing us today?
Yeah. So I've mentioned it a few times throughout sort of my answers, and I have a real interest in it, is this sort of concept of reactive applications. So for those of you who've perhaps not come across this term before, it's not new. It's just sort of been coined within this manifesto that's kind of been created. And it sort of revolves around those core principles of cloud native. So building applications that are asynchronous and message driven, so really going along those sort of lines of Kafka, etc. Building applications that are elastic, resilient, and highly responsive. And so as part of that sort of manifesto, that architecture type, I've been looking into things like MicroProfile have created something called Reactive Messaging, which really allows you to bring in reactive into your application in quite an easy manner, just using annotations. So in my demo,
let's do a step back and a little bit updating. So to my listeners who are not familiar and have not been in Java for a while, so what is MicroProfile?
Yes, we should cover that.
Yes.
So MicroProfile, for those of you who haven't come across it, is really a community-driven specification. So it has multiple different APIs, and the whole reason it was created was to enable developers that are perhaps creating Java or Jakarta applications to enable them to build applications that are ready for cloud native, that are microservice driven. So it enables APIs like health, metrics, fault tolerance, configuration, and also some Jakarta EE ones like JAX-RS, REST, etc. So really, by enabling these additional APIs and specifications, we can then use them in our Java and Jakarta applications so that we have the behavior that we need for those core cloud native behaviors. And one of them, as you mentioned, is reactive messaging. And so that's the one I've been taking a look at, and that's the one I'm going to demo in my demo in this.
So let's take a look at this. We will take a break, and Grace will walk us through this reactive messaging application. So stay tuned.
So for this demo on reactive, I'm going to be making use of the MicroProfile Reactive Messaging API, and that uses annotations. So just before I get into the demo, I thought I'd show you this quick diagram just to give you an idea of what we're going to be creating in the application today. So we're going to be using two annotations, at outgoing and at incoming, and those are essentially applied to an application's beans methods, and then they're connected together with something called channels. These channels are just opaque strings, so you can make it whatever you want to. In the diagram we have here, we've used a channel called order and a channel called status. And you can see we've been able to connect up those various methods using those annotations and matching them up using those channel names. So let's get started with the demo. So I'm going to be taking a non-reactive application and adding in those annotations to enable more of those reactive behaviors, and hopefully showcasing just how easy it can be to be able to add in reactive behaviors using open source APIs and toolkits like MicroProfile Reactive Messaging. So for this lab, I'm using the Open Liberty guides. So you can access that by heading to openliberty.io/guides, and you can find loads of different guides on here on lots of different open source APIs and integrations. The section I'm going to is Reactive Service, and I'm doing the guide creating reactive Java microservices. So when you hit that and log in, you can log in using any variety of social logins, including things like GitHub. You'll be taken to this cloud-based IDE where all you need is essentially, you don't need anything downloaded or any prerequisites on your local machine. You just need a browser. And we've set up the environment within this to be able to demo this lab and include any prerequisites you might need. So in this, we've got the instructions on the left-hand side, we've got the IDE in the top right and the terminal in the bottom right. If you don't have the terminal, don't panic, you can go to Terminal, New Terminal. Now, I am doing this demo and you can follow along, or you can do it in your own time. You can access this cloud-hosted environment for many of our guides and labs. So to get started, we're going to be taking this basic application and adding in MicroProfile Reactive Messaging. So our application has 2 microservices. We've tried to keep it as simple as possible to make it much easier for you guys to get your hands on with the technology and really understand the technology you're trying to learn instead of trying to understand the application. So in this, we have the system microservice. This is a microservice that essentially fetches the CPU usage of your system every 15 seconds. It then publishes this to Kafka, and then our inventory microservice then subscribes to Kafka and picks up this information and stores a list of all of your systems and their current system data, so CPU usage. We can then access that list by using RESTful APIs, so in this case we're using a GET request. So we're going to be adding in MicroProfile Reactive Messaging in between the system microservice and Kafka, so that interaction, and the interaction between the inventory microservice and Kafka. So we're really trying to enable that asynchronous, reactive, resilient, elastic behavior throughout our application here by making use of things like Kafka and MicroProfile Reactive Messaging. So to get started, we're going to use this GitHub repo. So this is open source. If you do want to go and check it out, you can. And we're just going to use these execute commands in the instructions page to be able to automatically execute them in our terminal. Alternatively, you could use the copy button and manually paste it into your terminal if you want to. I'm just going to run the execute button and it will automatically do it. So I've CD'd into our repo guide MicroProfile Reactive Messaging, and you can see our project and directory structure here within the Explorer view. Now in each of our guides, we have a start and a finish directory. The finish directory is essentially what you'll get to at the very end of this lab. So if you get stuck anywhere in between, you can always compare to the finish directory, or you can try it before you start building. We're going to stick to the start directory for this and just follow the instructions to create our reactive application. So we want to make sure, I'm just going to close this Explorer view just so you can see my code a bit better on my terminal. We want to make sure that we're in the start directory. So I'm just going to cd into start, or again, you can execute these commands that we have on the left-hand side. As I mentioned, the system microservice is the one that's going to be publishing events to Kafka. And that's the one we're going to edit first. So we're going to create this system service class. So I'm going to execute this touch command that creates that for me and use this open button to be able to open it in my IDE. Alternatively, you can navigate using the Explorer to find this class, or you can use the file open function. I'm just going to use the button just because it makes it a bit quicker. We can then copy and paste in the code we provided here, paste it into our IDE, and remember to save. This does not automatically save. What you can see here is that we're importing the MicroProfile Reactive Messaging outgoing annotation. Because this is publishing events, if you remember from this diagram here, because we're publishing, we're using the outgoing annotation. So we're using, you can see it further down, the outgoing annotation here to the system load, using the system load channel. So this is what we've called the channel. Now, usually when we're connecting 2 methods together or 2 annotations together, we'll call it a channel if it's internal. If it's external, we have a different name for it, and it's called a connector. And you'll see that we're using connectors in this application because we're connecting to an external messaging broker, Kafka. And we'll show you that later in the configuration that we create for these microservices. Now, as well as using the MicroProfile Reactive Messaging specification, we're also using a couple of other reactive libraries, for example, RxJava, and you can see this in our importations here. So we're using a method called flowable, and this enables us to be able to essentially set the frequency of how often the system service is publishing the calculation to the event stream. And we're specifically using flowable because this allows us to add in back pressure as well to our application. So now we have an architectural diagram that looks a bit like this. So we've been able to use MicroProfile Reactive Messaging to connect our system service into our Kafka broker using more reactive and asynchronous methods. So the next thing we need to do is then connect in our inventory microservice. So now we need to go and create the inventory resource class. So I'm just going to use the execute command again and then open that up in my IDE. Again, just copy and paste the code we provided for you here. Scroll to the bottom, use the copy buttons, and remember to save. So in this, we're using the @incoming annotation because we're consuming events from Kafka. We're still using the same channel because this is again how we connect up our different annotations. And you can see that again in the import here. So now we have an architectural diagram that looks a bit more like this. So we've been able to use Reactive to start connecting these various elements together in a more asynchronous manner. The next thing we need to do is enable configuration for us to be able to use things like the MicroProfile Reactive Messaging connectors for Kafka to be able to really enable these connections. So the first thing we're going to do is create it for the system microservice. So again, using this execute button, I'm going to create this class and then open it up in my IDE. Copy and paste the configuration we provided into this class here. So what you can see is that because this is the system microservice, we are now using the outgoing annotation. So we've got outgoing in our configuration here. Now, because MicroProfile is a specification, you will need to use an implementation of it to be able to actually make use of these APIs. We're using the Liberty implementation. So this is OpenLiberty, which is an open source cloud native runtime. So because we're using that, and because we're connecting to Kafka, we're using the Liberty Kafka connector. Now the connectors that are available will differ depending on what implementation you're using. We're also setting the topic here, so this is what topic we're publishing to on Kafka, in this case, system load, and then we've got a serializer to be able to change our object into JSON for Kafka. The next thing we're going to do is create a very similar file for our inventory microservice. So again, using the touch command, we're going to create the file and then open it up in our IDE. Copy and paste over the configuration and remember to save. In this case, because it's the inventory microservice, we're consuming that information from Kafka, so we're using the incoming annotation. So we've got incoming in our configuration. We're still using the same connector though, because we're still an OpenLiberty application trying to connect to Kafka, and we're still using the same topic because we're still trying to consume the same information we've just published from the system microservice. This time, however, we've got a deserializer instead of a serializer because we're going in the opposite direction, and we've got an additional configuration here. So this is the consumer group ID. Consumer groups in Kafka enable you, if you have multiple consumers, to join into the same consumer group. And this concept means that Kafka can guarantee the ordering of the events and how they're processed, and can also ensure you don't get duplication of processing events when you're consuming from the same topics. So this can be really useful if, for example, we had multiple inventory microservices all trying to consume from this system load topic. However, for simplicity's sake, just in this one, we've just got one. So the next thing you can do is configure the server. So if we execute this command, we're just creating a server.xml file, and we can copy in what we provided here on the left-hand side. So as you can see, we've got the features that we need, for example, reactive messaging, and we're also making use of several other features offered by MicroProfile, which includes things like health, concurrency, config, for example, and you can find other labs and guides on the OpenLiberty site that go through each of those if you want to learn more about them. We've already configured the server.xml file for the inventory microservice. It's just identical to this one. And the last thing we need to do is to create essentially a build file. So in this case, we're using Maven. So we can execute that, open up our pom.xml, and insert all of the dependencies that we need for this application. So if we copy that in, save, what you can see is we're importing all of the different dependencies we need. So for example, we have Eclipse MicroProfile, which includes all of the standard APIs that come as part of MicroProfile, including things like configuration, health, CDI, JAX-RS, etc. Now, because MicroProfile Reactive Messaging is a standalone project, still developed by the MicroProfile community, but just not yet part of that standard stack, you will need a separate dependency for it. And you can see other dependencies like, for example, Kafka, which is obviously needed for this application, and other reactive libraries like RxJava, which is a reactive library that really enables us to have that reactive behaviors at the programming level. So now that we've created all of this, you can continue this guide if you want to and see just how easily you can then deploy it and start testing the application. But hopefully what I've shown you through this is just how easy it can be to add in reactive behaviors into our application using things like event-driven architecture, using tools like Kafka, and using tools like MicroProfile Reactive Messaging to ensure those communications and integrations and interactions between the various different components of your application can be made to be more reactive.
And we're back. We're glad that you stayed for us for a while talk. Grace, thank you so much for this demo. It was
Absolutely.
awesome. And one of the questions that I usually have, like unrelated to technology at to my guests in this podcast, is that maybe can you recommend anything that maybe you recently read some interesting book, or maybe you list some interesting, I don't know, the album of your favorite band. So something that will give them a little bit more inspirational, less technology, and
Yeah, well, I was actually in the Women in Technology breakfast this morning.
Yeah.
And we had we had a really amazing speaker who was talking about, she'd founded Women Who Code, which is a great initiative, getting more women into technology. And just listening to her story of, all the people that she interacts with because obviously I think we're all aware that we have a diversity issue within technology in general. And I don't think it's necessarily helped by the enterprise nature often of what we're involved in. And I think a lot of women don't necessarily see opportunities, for example, or what they could achieve.
Yeah.
So it was really nice to listen to the stories of women who had come here. It was their first conference, for example, or they hadn't done this sort of thing before, and being able to step outside their comfort zone, welcoming them into this community, welcome them into Java, into conferences, etc. It was really nice to be able to, and inspiring, to hear their stories and to be able to encourage more women into technology, because I think it's fantastic to get more diversity within this industry.
I agree. And where we can learn more, what information that listeners and watchers who watching this the video, what they can learn and where they can learn more about this.
Yeah. So there's the Women Who Code initiative. So they are a whole team of people all over the world, in most major cities, and they have a website, Women Who Code, and you can check that out.
We'll put the
the URL
as we do
wherever it needs to be.
Exactly, as we're doing this on YouTube, so you can find everything there. Everything there.
And this is a really great website. You can get involved. There's loads of projects, volunteering, mentoring, that sort of stuff. And again, you can find them in lots of cities around the world. So hopefully, wherever you're listening from, there'll be one nearby you. So if you're interested, definitely check out that initiative.
That's great. Grace, it was great to have you at the Kongcast. Hope we'll see you around the globe more in the different conferences, and we will cross paths more. And with this, thanks so much for being part of Kongcast. My name is Viktor Gamov, and as always, have a nice day.